Welcome back. We would like to continue our discussion on the slope. In this section, we will deal with parallel and perpendicular lines. Let's first review the slopes of parallel lines. Well, we recall that if two lines are parallel, they have the same slope. If two lines are perpendicular, then their slopes are negative reciprocals of each other. In this example, we would like to write an equation of a line parallel to a given line. So write an equation of the line passing through the given point, a negative 2, 5, and parallel to the line whose equation is given by y is equal to 3x plus 1. And then finally, we want to express the equation in both the point-slope form and the slope-intercept form. All right, so let's see here. So the given line, y is equal to 3x plus 1. So the slope of this line, of the given line, is 3. And the line passes through the point a negative 2, 5. So using this information, we can now write the equation of the line. We're going to use the slope-intercept form, the point slope. Point slope says that y minus y1 is equal to m times x minus x1. So we have y minus, the y coordinate of the given point is 5, is equal to m, the slope is given to be 3, x minus the x coordinate of the given point. The x coordinate is a negative 2. All right, so we have y minus 5 is equal to 3 times x plus 2. And this is actually the point slope form. This is the point slope. So we're to express it in both the point slope form and the slope intercept form. So to express the equation in its equivalent slope intercept form, we merely just solve for y. So we have y minus 5 is equal to 3x plus 6. Y is equal to 3x plus 6 plus 5. So y is equal to 3x plus 11. So the equation of the line is y is equal to 3x plus 11. And this final form is in the slope-intercept form because the slope is 3, the y-intercept of the line is 11. In this example, we would like to write an equation of a line perpendicular to a given line. So the first part of the problem involves finding the slope of a line, of any line that is perpendicular to the given line. All right, so we have the equation of a line, and we want to let's first find the slope of this line. In order to do that, we need to solve for y. So we have 3y is equal to minus x plus 12. Divide by 3. The y is equal to a negative x over 3 plus 4. 3 into 12. So this is the given line expressed in the slope-intercept form. And in the slope-intercept form, the slope is a negative 1/3 of the given line. But the line that we want to find the equation of is perpendicular to the given line. So if the given line has a slope of a negative 1/3, the slope of a line perpendicular to this would be the negative reciprocal. So the slope, say, the line that we want is going to be the negative reciprocal of, so this is going to be 3 over 1, which is 3. So the slope of the line that we want is 3. All right, so I now have a line with the slope of 3, and I know, so okay, that's all we wanted to do in this one. So the line, the slope of the line is 3. In the next part, we want to write the equation of the line passing through the given point, a -2, -6, and perpendicular to the line whose equation is x plus 3y minus 12 is equal to 0. Express the equation in general form. All right, so in this equation, we've already determined the slope. We're going to use the slope from part A. We found that the slope is going to be 3. And the point is a -2, -6. All right? So we're going to use this information to find the equation of the line. And again, we're going to use the point slope form to find the equation of the line. So y minus the y coordinate of the given point, y minus a -6, is equal to m, the slope is 3, 3 times x minus the x coordinate of the given point, a -2. Let's simplify. Y plus 6 is equal to 3 times x plus 2. And it says express the equation in general form. So this means that we want to simplify, so we have y plus 6 is equal to 3x plus 6. So in general form, we can express this as a -3x plus y plus 6 minus 6 is equal to 0. So we have a -3x plus y is equal to 0. So this is the equation expressed in general form. Welcome back. Let's now discuss the average rate of change of a function. We define the slope of a line to be the change in y over the change in x. In other words, we interpret the slope as the rate of change. It describes, in other words, how fast y is changing with respect to x. Now for a function, let's assume that we have 2 points on the graph of a function. So the average rate of change, denoted as delta y over delta x, is going to be the change in the y over the change in x. All right, so if we look at the point x1, f of x1, and the point x2, f of x2, we're basically just using the definition of the slope, the change in y, and by the way, we denote the change in y as delta y. We say that the average rate of change is defined as delta y over delta x. So it's the change in y would be f of x2 minus f of x1 divided by the change in x, x sub 2 minus x sub 1. So this is what we call the average rate of change of a function. Let's look at an example. So we have an example where we have to find the average rate of change of a particular function from, say, x1 is equal to 0 to x2, which is 1. So from 0 to 1. So actually, I want to find the average rate of change of the function f as x changes from 0 to 1. All right, so let's do that. So we defined the average rate of change of a function to be delta y over delta x. Delta y we define to be what? F of x sub 2 minus f of x sub 1, all divided by the change in x. All right, so let's compute this. So our function is f of x is equal to x cubed. And so we have f of x2, f of x2 is 1, minus f of x1. F of x1 is 0. All divided by x sub 2 minus x sub 1. So this is 1 minus 0. All right, so let's compute this. F of 1 is going to be, our function is defined to be f of x is equal to x cubed. So we want to evaluate the function at 1. So f of 1 is going to be 1 cubed minus f of 0. F of 0, x is 0, so that's 0 cubed divided by 1 minus 0. Simplifying, we get 1 cubed, 1 minus 0 over 1. 1 minus 0 is 1. 1 divided by 1. So the average rate of change of the function as x goes from 0 to 1 is 1. The average rate of change of that function is 1. Let's do another example. This time, x changes from 1 or goes from 1 to 2. So let's see how to compute, in this case, the average rate of change. Again, we want delta y over delta x. So this is going to be f of x2. x2 is 2, so that's f of 2 minus f of 1. All divided by the change in x. So we have 2 minus 1. F of 2, our function is f of x is equal to x cubed. So that's 2 cubed minus f of 1. F of 1 is 1 cubed, all divided by 2 minus 1. 2 cubed is 8. 8 minus 1, 1 cubed is 1, divided by 2 minus 1 is 1. 8 minus 1 is 7. 7 divided by 1 is 7. So the average rate of change of the function is 7. One more example. In this example, x changes from a negative 2 to 0. Again, to compute the average rate of change of the function, we have the change in y. So this is going to be f of x2. X sub 2 is 0. So this is f of 0 minus f of x sub 1. X sub 1 is a negative 2. So this is going to be f of a negative 2 divided by the change in x. The change in x, so this would be 0 minus a negative 2. F of 0, our function again is x cubed. So f of 0 is 0 minus a minus 2 cubed all divided by 0 minus a negative 2, which is 2. So we have 0 minus a negative 2 cubed is a negative 8. So our final answer is 0 minus a negative 8 is 8. So the average rate of change of the function is 8. Let's go back here. I see 0, we've got our denominator here. So that's 0 minus a negative 8 over 2. That's 8 divided by 2, which is 4. So the average rate of change is 4.